Okay, there you go. So yeah, so there are a number of basic data types within Grasshopper, and within programming in general. There's this concept of objects. Objects in programming are kind of like a general concept that tries to mimic everyday stuff. So it's kind of like an abstraction. So circles, points, numbers, they're like a programming abstraction of everyday things, which are called objects. So objects have properties and they have functions. They can perform actions. So for example, a property of an integer is I don't know, in this case, just the representation of the number. And a function of an integer is the addition or subtraction, right? And once we start building up more complex data structures, we have more complex properties and functions. So for example, a point, it's a vector. So a vector is kind of like several integers or floats put together with specific mathematical properties, etc. So yeah, Grasshopper has a number of basic data primitives like integers. First of all, the interface. I think I can like skip the whole interface thing. How many of you guys are even familiar with Grasshopper? How many of you guys have opened Grasshopper before? Just I would say half and half.
But I think Sally gave a workshop this week.
Sally gave a workshop this week.
The base of the
So I can skip the interface. Okay, cool.
Yeah.
Sounds good. So yeah, you know where to find this data primitives. You can also double click on the canvas. This is called the canvas. It's in theory infinite. And one useful way that I find to keep all of this organized is think of it as a history. In fact, Grasshopper, before it was called Grasshopper, was called explicit history. So the data flows from left to right. So yeah, you can double click on the canvas and type integer if you want. Your keyboard is a little bit distracting, but yeah, integer, and we have two different types of nodes within Grasshopper. All these nodes or components. There are nodes that are kind of constructors or make things, and there are nodes that just kind of like hold information. We can think of them as data containers. So all the things, or most of the things in this first two tabs, the geometry and the primitive, those are containers. So they just hold information. They're kind of like a bucket for information. And they can also transform among data types. For example, here I have a 5.2 number or float, and when I plug it in to an integer, it becomes a 5. So kind of like takes a float and transform it into an integer from left to right. So information is flowing from here and goes into this bucket and gets transformed into an integer. Doubles or floats are just integers. They can have an infinite number of decimals, etc. Strings in general in Grasshopper, because we are used to thinking about geometry. Strings are not necessarily that useful for us, but it's always useful to add little notes or scribbles to describe what we're doing at a specific time of this kind of like scripting process. But I kind of like believe that that design has to move kind of like beyond pure geometry and has to incorporate other aspects that go beyond the pure geometrical properties of an object, but that's kind of like a broader discussion. Anyways, building on top of this basic data types, we have points. If you guys double click and type construct point, a point is conceptually a vector. What is a vector? Someone? What is a vector? No? Vector? What's a vector?
Line.
A vector, it's not a line. A vector, yeah, exactly. So a vector has that was a good try. Conceptually, a vector can be thought as a line because it has an origin and a direction, right? And a point in a conceptually, it's similar to that, except that it doesn't have a direction. It has an Euclidean form, so an x, y, and z value, and it represents basically a point in space. One important thing that you can do is select many components or nodes with your mouse. You can hit the spacebar and turn them on and off with this face, the folded face, and the other one that doesn't have the blindfold, because otherwise it can be distracting to be looking at multiple geometries at the time. So right now we are looking at this point that we just created. We can also add sliders. One useful trick is a slider is basically a node with different values that you can change easily. One useful way and quick way to get a slider into Grasshopper is to double click on the canvas and type a number. Let's say I want my point to be on 4.5 x. Something interesting happened. As I plugged in the slider to the x input, this changes on the fly, which is a very useful visual metaphor. All these nodes have inputs and have outputs. So they get information in, they do some process or some function, and they result in some other thing. They have an output of the process. Some of them have a single output, others have multiple. A colleague in Berkeley used to say, or used to think about this components as having like little nipples that you plug information in, and an output nipples. So you can think of them in whichever way you want. But yeah, anyways, we can control how this component manipulates information and constructs a new geometric entity in this case. If something doesn't make sense or you guys have any questions, just let me know. So all of this are really basic data types.
So, quick question. Could you go back? Yeah. So this 5.2 h.
So that is something that's a good question. Grasshopper doesn't have any inherent units. The units are based on the model space. So Grasshopper, it's kind of like a parametric space, and it depends on Rhino. So whatever units you have set in Rhino, those are the output units. So in this case, I can click on Rhino and type units, and this is actually millimeters. I actually hate metric the imperial system. I'm kind of like a metric system lover.
We're all the same page. Everybody not from here hates it.
But we live here, so I'll just stick to it. But yeah, I'm gonna switch it to meters.
For my favorite number is 3/16 of inch scale. I just can't understand how this scale, where this scale came from.
Yeah, it's a little bit ridiculous, but that's a good question. Cool. So I'm just gonna erase this. Vectors. Grasshopper actually doesn't have a vector. Or Rhino doesn't have a vector data type. But Grasshopper can display vectors. So as I was saying earlier, a vector has an anchor point and it has a direction. So in this case, this vector has its anchor or its origin at the 0, 0, 0 coordinate, and the direction of the vector can change. But what are vectors useful for? Any idea? So when we're modeling, sometimes we make transformations. So for example, if we want to move an object, every time you move an object in Rhino, there is a number of geometric operations going on in the background. So in computational geometry or computer graphics, we call all of this matrix transformations, and it has to do with vectors transforming the objects as a basic operation. And then there's a lot of linear algebra going on in the background that you don't have to worry about. But for example, if I want to move this point to a specific place in space, what I can use is a vector to show the direction where I want this to be in. And all of this data primitives kind of like build on top of each other. So if we put together a point and a vector, we can create a plane. So a plane basically is an abstract data type because it doesn't have a surface, but it does help us locate stuff. So for example, if we want to project geometry onto a specific plane, we can transform the direction of the plane easily. In Grasshopper and Rhino, planes are also coordinate systems. So we can specify geometry or geometric properties or positions according to planes. Next, we have lines. What's a line? What do we need to create a line? 2 points at least. Yep, exactly. So as you can see, we're kind of like building more complex geometries or more complex data types based on this primitive data types. So in this case, I have a point at the origin of the coordinate system, and then another point that I can change. And if I put those together, I get a line. So every time you're kind of like wondering about what data types every component takes, you can hover over the inputs. And it's got some sort of like a visual display that gives you information of what's needed. Okay, all good? Good. Circles. Circles require a plane and a radii or a radius value. Why do you guys think we need a plane to construct a circle?
Because line, just
Yeah, I mean a circle can have any inclination, right?
mm-hmm.
So if we want to have a circle on the xy plane, we can pass a point. So if I pass this point into this input, the circle is going to be parallel to the xy plane, right? But what if I want the circle to be tilted? I'm going to have to change its plane. So Grasshopper is very flexible in this way. If we just want to perform a very basic operation, we can pass in a basic point or a vector. But if we want this to have more specific properties, like an inclination or some sort of like tilted value, we can pass that. Also, what do you guys think if would happen if I pass in, instead of 1 point, multiple points? So right now, this is just 1 point. So I'm giving this circle 1 point value. What would happen if instead of passing in 1 point, I pass 5 points? How many circles would I have? Or would I get? 5 circles, exactly. So within programming, this is called kind of like functional programming, where you have a function or an operation, and depending on the input, you can have multiple results. So it behaves differently according to the input. So if you pass in a list or a collection of points, it's going to create a collection of circles. Cool. An arc is similar to a circle, but differently. You also need to pass in a domain of the circle in radians. So what do you guys think a domain is? A domain has a starting value and an end value, right? So what's the domain of a circle?
The point.
Let me rephrase it. How many pies is the radius of a circle? Or 2 pi. 3.14 blah blah blah. So if an entire the whole circle, this whole circle's domain is 2 pi, have a circle, or this arc is 1 pi, right? So what would I have to pass? What value would I have to pass in if I want a quarter of a circle?
Just 1 pi.
0.5 pi, right? Half a circle is pi, quarter of a circle is 0.5 pi. So we have a pi constant actually. So if you double click and type pi, it will give me this component. And by default, pi has a 1 as a value. But I can also give it a 0.5 value. So I'm going to double click and type 0.5. So I'm going to plug this in and plug this into here. So now I get a quarter of a circle. Okay, cool. And building on top of all of this, what's a polyline? A polyline is a collection of line segments, right? So if I need 2 points to create a line, how many points would I need to create a polyline? 3, but at least 2 in Grasshopper. Yep. So this is what I was talking about. If you guys grab a panel is this yellow thing with a scribble in it. You can just drag and drop into the canvas. The panel is very useful. It can like help us debug. So whenever we have a problem or we need to look at what's going on within one of the components, we can use a panel. It kind of like displays the information. So in this case, this point component is actually constructing what we call a list of points. So it's a collection. So this list of points creates a polyline with this component. And the list of points is generated through a series of components, which basically creates a series of numbers within a given interval. Is this clear? Yeah? Kind of. Okay, let's go back a little bit. So there are like multiple ways to construct a series of points, right? I can copy and paste this component 20 times or whatever, but that's kind of like tedious, and it's difficult to do, difficult to control. Another way to do it is just generate a series of numbers with a given interval or a given rule. All we're doing is constructing rules. So we can construct a series of numbers based on a rule. So let's double click and type series. So this component creates a series of numbers, right? If you hover over, you can see what it actually does. It takes in a first number in the series, a step size, and a number of values in the series, right? So what values would I get by default if my first number is 0, the step size is 1, and we have 10 different values? How many points will I get? 10. That go from what? From 0 to 9. Exactly. Perfect. So now if I use these points or these numbers to create a point or a series of points, what would I get? I'm gonna type construct point. Now I get 10 points, right? 0, 1. They are all on x0. And what I did here was just use a random component. This is actually not random, it's pseudo-random, but that's a different kind of like computational discussion, generating random numbers. But in any case, this takes a random seed and multiplies a number by a random seed. So if we double click and type random, this one takes a domain, so a minimum and a maximum number. By default is 0 to 1. It takes a number of random values and a seed. The seed is kind of like the let's say if we want a number of random values to have the same value, we have to use the same seed. It's kind of like a larger discussion.
Just a quick question. So how did you get this point? You double click, you wrote point, but which one?
So I double click on the canvas, and I type construct point. Yeah. Maybe like a year and a half ago, they changed the names of a lot of components. It used to be point. Yeah. So random. For a random number, all we need to do now is use the same number here. So if we're using if we're getting 10 values or 10 numbers, what we need to do is get a 10 slider and use the same value for both the series and the random number.
So this is the 20? No,
Sorry?
It's a 20.
It's a 20?
20 point?
No, it's 10. Because this is, let me show you.
Okay.
So here I have 10 numbers. They're separated by 1 unit, right? Whereas this one is 10 numbers, but they are randomly spaced or pseudo-randomly. Generating random numbers is a very difficult task. So these are just pseudo-random numbers. In any case, if I use this random series of numbers to control the y, my points are not gonna longer lie on the x-axis. They're gonna be mapped to random values, right? So let's look at both values. So this point, it's at 0, comma 0.77, right? The other one's at 1 and 0.40, right? So it's kind of like the operation that Grasshopper is doing in the background. It's matching both lists. And that's what functional programming is. It takes containers or objects and it maps them together. Okay, if I'm going too slow or too quickly, let me know. So yeah, of course, if you have a list of points, you can put them together into a polyline. Okay. So Rhino, different to AutoCAD or other modeling software, it's based on NURBS. Does anyone know what a NURB is? Nope. Well, NURBS have its origin in the car industry. So in the 1950s and 1960s, creating curvatures on cars was a very difficult task. There were no computers, and even furthermore, creating double curvatures like Gary's buildings was a very difficult thing to do. So this French dude that worked at Peugeot came up with this idea of coming up with Bezier curves. So a Bezier curve is, he basically put together strings with pulleys, and based on weights, he would be able to manipulate curvature. So if you look at the way this curve is constructed, it basically has anchor points. So each one of these points would be one pulley, and there's a string going through it, right? So it doesn't go exactly like the pulleys, but it kind of like softens the profile of the curve. So Bezier curves are kind of like the origin of NURBS curve. So in the background of Rhino, there are a bunch of arithmetic operations happening to render all these curves that you guys see. But basically what you have to do or provide is a series of points and a degree. The degree of a curve is how stiff or how freeform the curve is. So a curve with degree 1 is basically going to be a polyline. As you increase the degree, it kind of like softens its shape. Any questions? No? Good. And finally, the last important basic data type that we're going to look at are booleans. So a boolean is a true or a false value. The way digital computers work, it's kind of like binary. So we have a binary state. So anything that you kind of like construct computationally, it's then mapped into zeros and ones. So truths and falses. What do you guys think truths and falses are useful for?
It's like a switch, basically, right?
Sorry?
It's like a switch, basically.
Exactly. So they help us make decisions. They help us evaluate conditions and make decisions based on them. So true and false. In this case, I have a filter. And two different inputs. So I have on one hand a point and on the other a circle. So false is always going to evaluate to 0, right? So what this is doing now, it's taking an input, a 0 or a 1, and then it sort of like decides where to go, whether input 0 or input 1. So if I switch this to true, I get the circle instead of a point, right? So this is basically why they're going to be important for us, because they help us filter different conditions. In programming, we have different programming paradigms. One of the most important ones is imperative programming. So we can like make decisions based on conditions. We sort of like decide what the flow of the program or the code is based on different conditions. So in this case, the condition is whether or not this is true or false. So we can start thinking about a series of rules that may trigger points or circles in this case, or in your case, for example, those of you who are dealing with sun or wind or whatever, you guys can set up rules. If the wind or the sun exposure is more than a threshold, then open up my blinds or my system. If it's less than this, close it. So this is kind of like how you start thinking about booleans. Any questions about basic data types? Ask me anything.
No, I understand the difference.
Uh-huh.
Take parameters and vectors, right?
Sorry?
Grasshopper understand the algorithm as a parameters and vectors.
So Grasshopper takes inputs and outputs.
Okay.
So the inputs are kind of like parameters. Grasshopper is kind of like parametric. So it's based on let's say parameters or values. It's kind of like a linear vector. Any operation within Grasshopper is a linear vector. We have a start and an end, and conceptually. So any set of conditions start with a beginning condition or beginning data, and as we chain operations together, we can like join these multiple parameters into a single vector or a single set of conditions or functions. So it takes inputs. The inputs can have different data types, and it gives us outputs, and it's linear. So nothing is nonlinear in nature. It all describes a linear vector. If that makes sense. If it doesn't, ask me more.
I mean, the parameters has point, and the vector has point. What's the difference between the 2 points?
Oh, between a vector and a point?
Yeah, the vector and the parameters. So if you open the parameters, it got points.
For example, tell me which one do you want me to look at?
I just want to understand the difference between parameters and the vectors.
Parameters not like a specific thing.
So all the inputs are going to be parameters.
So the vector could be considered
A vector is a data type.
Okay.
So it's just a subset of the data types. Data types help us build more complex objects. So data types we have from very simple ones like integers and floats, booleans, etc., to more complex things like surfaces or NURBS curves. So as we chain different data types together, we can construct more complex objects. So for example, a line is the result of 2 points, right? So in this case, the parameters coming into the point component are what? Numbers, right? Because we define a Euclidean point in space, or a Euclidean value. Then with the points become the parameter or the inputs of the line, right? So we're kind of like building up on data types. So back to your question, vector is a subset of the data types that exist in Grasshopper. But, is it better? Okay, cool. Anything else? It's all good? Cool. All right. Data can be inherited, and is in fact inherited from left to right. So as you guys have seen, we can construct more complex data types from more simple data types. So for example, what if we want to construct a line? We can double click on line, double click and type line. There are multiple ways of constructing a line, but we're gonna create a line between 2 points. Okay, so I have my line component. I'm gonna need 2 points. So I'm gonna double click and type construct point. And I can copy and paste this one. So I'm gonna have the first one at the origin and the other one at this 5, 5 or whatever. So I went from something simple, from a number to a point to a line. So all the data and all the information is flowing from left to right. What if I want to create a surface with this line? For those of you who are familiar with Rhino, how would you create a surface? There are many ways to create a surface, right? The easiest way is to extrude a line. So the same set of operations that you guys come up with in Rhino are available to us in Grasshopper. It just has to be in a procedural manner. All right, so let's double click and type extrude. So let's go with this one. So what does extrude take? A profile curve or a surface? So I have a profile curve here. I have a line, right? So I'm gonna connect the line to the extrude. What else do I need? An extrusion direction. Yeah. So what is an extrusion direction? If you guys look at it, it's a vector. You guys see that little line, that little arrow icon? That means we need a vector. So we can define a vector in multiple ways. Here what I'm doing is I'm extracting the point and I'm converting it into a vector. So now it has a direction. And I'm doing a vector operation, but that's actually not needed. It's a vector cross product, but let's skip that. Let's construct our own vector. So let's type construct, or vector actually. Let's type vector XYZ. So this is similar to to a point component, except these values are all going to be anchored at the origin. So let's say this is my vector. 0, 11, 11. So what happened? It extruded this surface according to the 0, 11, 11 vector.
What is the 0, 11?
What? That's a good question. Let's start with a more basic way of looking at it. What's a 0, 0, 11 vector? It is a vector that has its origin at 0, 0,
Yeah.
so here,
It's like that.
and then the direction it's on 0, 0, 11, right? So everything else is 0, but the z value is 11. Does that make sense?
Yeah.
Okay, cool. And we can increase the value. We can also combine
So
it.
it will go only until.
Sorry?
So it, okay, never mind.
Yeah?
Yeah, yeah.
Okay, cool. All right. So here we are extruding a curve. So if we extrude a curve, we get a surface, right? What if we want to extrude a surface? What are we gonna get? We're gonna get solid, yeah. Let's just copy and paste this one. And let's get the cross product. Do you guys know about vector operations? No? Well,
What was that called?
But did you write cross what? Reference?
so I double clicked and I typed cross product. So a cross product of two vectors, they call it the rule of thumb. So we have a vector and another vector. So if we multiply both vectors, we get whatever is in between, right? So if we multiply any vector by y, we're going to get the perpendicular to that given vector, right? So let's do something like that. Let's get this
What did you type to get that?
cross product. Yeah. This one. Good?
Yeah.
Okay, cool. So we're going to use this vector, and then I'm going to double click and type y. So let's display this vector to see what's going on, because this is kind of like abstract, right? If you double click and type vector display, this tool lets me visualize the vectors. And let's use 0, 0 as the anchor point. Okay, so the first vector that we have is this one that goes along the surface that we just extruded. And in this case, the cross product of that given vector and y it's perpendicular to that one, so it goes in the opposite direction. So if you guys look at your hand, at your finger rule, you guys can point this finger up and the other to the y direction, and you get exactly the opposite, right? So this one is going up in that way, and then y, and you get the opposite. So we're going to use this solid vector to extrude it. So now what do I get? I get a solid. Right? So I went from numbers to points to lines to surfaces to solids. Can I go the other way? Can I go backwards? Can I deconstruct surfaces or solids and create more simple units? Yeah. Yeah, because all those properties are still part of our object. They're just simpler. So what I can do is, let's say I want to, Mona, do you want to use my computer? So I can explode and get the individual faces of this box or box-like object by double-clicking and typing explode. I think it's actually deconstruct. Deconstruct brep. So this is one of those components that give you multiple outputs. What does this component give me? It gives me the faces. What are the faces in this case? The faces are all of these planes that construct the surface. So how many planes do I have? 6? So it's a list of 6 faces. It gives us the edges, so all these lines, and it also gives us the vertices, so the 8 vertices or corners of this box. From a given surface, I can subdivide a surface into smaller points. So let's type surface divide. This one, divide surface actually. Okay, so click divide surface. What does it take? It takes a surface to divide and a number of segments in U and V direction. Why in U and V direction? Because we are working on parametric space. So surfaces have a U, instead of being an XYZ location, all the points within a surface live in a U and V space. So let's think of a surface as being sampled in U and V points. So it's kind of like an address instead of a Euclidean address. Does that make sense? Maybe?
If not, you can ask.
Yeah. Is there like a marker here I can use?
It should be a...
There's no marker. I think I can find a video. There we go.
It doesn't have a Z because it follows the surface, no?
Yeah, it doesn't have a Z because this is parametric space.
Yeah.
This is not Euclidean space. So if you guys look at this, the surface is divided in quads, and this is a very important concept to understand. every time we're sampling a surface, we're looking at their u and v values. So we don't use a z value because it's within parametric space. It's a different conceptual space. It's not a Euclidean space. It's just parametric space, u and v's. So which one would be my 0, 0 point in this surface?
Where the U and V meet.
It would be here.
Yeah.
Which one would be the 1 and 1?
1 and 1.
At the end. So 0, 1, 1, right? 0.5, 0.5. And that's a super important concept to understand. Because we're going to be dealing with parametric space. Okay, so what this is asking for is the number of divisions in U and V. And a surface. So which one of these outputs returns a surface? The faces. Yeah. Cool. So that divided this set of surfaces into 10 and then number of points in U and V direction.
How it divides? This on 10, is it the default?
It's the default. You can modify this. Let's say 20.
How do you know what the default is?
When you hover over it,
yeah,
it has a little value. So in this case, this is 10. I can make it 20.
Awesome.
Now it's super dense. Can make it 100 or even more, but I'm gonna kill your computer. Okay, cool. Makes sense?
Yeah.
All right. Let's move on. We can take a 10-15 minute rest break at 3 if you guys want.
Sounds good. It's a lot of burning.
Yeah. I was teaching machine learning on Thursday,
Yeah.
and that's like, because you're like dealing with non-parametric operations. It's kind of like a crap show, but cool. So constructing a line. So far we have seen one method of constructing lines, which is basically passing 2 points, right? But what if we only have 1 point and we want to construct the line based on a transformation? A direction. Or I guess another way to put it is if I have a point and I want to move it, that gives me two points, right? So let's recreate this whole definition. These files are, I guess, by default or by convention called definitions. So when people or when architects are talking about the Grasshopper definitions or Grasshopper files. Let's double click and let's type construct point. And now let's double click and let's type move. Okay, so what does move take? Takes a base geometry. It can move anything that is a geometry. That's kind of like a universal input. In this case, we're going to move the point, and it also takes a translation vector. So you can think of a translation vector in a similar manner as the extrusion vector. So it just points towards where you want this to be moved. So let's construct a vector again. Double click, type vector xyz. By default, this is 0, 0, 0. One nice trick is when you double click and type a number, depending on whether or not you make this integers or decimal. Let's say if I say 20, it's gonna default to integers. If I say 20.00, it's gonna give me floats. All right, so now I have vector, and I can move this point. And now what do I need to do to construct a line? Just type line, A point and B point. Cool, that was easy. Good, any questions?
I think the students who are not in our class doesn't have access to the files, right? We gave them a USB. I gave them.
You have it's on the Dropbox. Yeah, I uploaded it to the Dropbox that Mona invited me to.
So there is a Grasshopper folder in our Dropbox, which all of you have access to them. And the students who are not in our class, please transfer the file with USB to them.
Can you kind of re-explain what it is?
Yeah. So what?
Kind of followed along, but then got lost.
So what did I do? I started with a base point.
Yeah.
That's at 0, 0, which is this one. And there are like multiple ways of constructing new points or new point entities. So in this case, what I'm doing is just translating or moving the original point into a new location. So if you get a move component, the move component needs geometry and then a direction to move the geometry to.
Okay. And then when you did the vector, you gave it x, y, so it moved in that direction.
Exactly.
If
So
you only did z, it would only go up.
I wish I had a marker, but basically a vector. You can think of this as a vector.
Yeah.
It has an origin and it has a direction, right? So here, the origin of all the vectors in Grasshopper is going to be 0, 0, 0. So in this case, my vector goes from 0, 0 to 21, 28. So that's the direction. And you use this vector to move this point. So you move it to the tip of the vector.
Okay. And then to construct the line, you basically did use 2 points, no?
I use 2 points.
But they're the same point.
But they are an instance of the same point.
Okay.
But that's kind of like computer science methodology. So
it's like the origin and then to wherever you moved it.
Yeah, exactly. You apply some transformation to the point and then something else happens.
Yeah.
So you apply a series of transformations to it. Cool. All right. Let's look at another file, and then we can take a break. So let's open 1.4b. So this one actually builds on top of the other definition. Whoa, I don't know what happened.
There's no 1.4.
There's if there's no 1.4b, we can build that from scratch. It's okay. Yeah, it's okay. It's no big deal. All right, so let's right click on this point container. Click on set one point. I'm gonna turn all of this off. To turn it off, what you need to do is select it, hit the space bar, and click on this disable preview. Okay, so the first part of the definition, you guys are already familiar with it. What we did was create a line by moving a point in space. Okay. So what if we want to construct a truss? If you guys started modeling a truss in Rhino, what would you guys do? Make a line, move that line, then we have to divide the line into a series of points, join the points, and get the diagonals, right?
Yeah.
So that same procedure, we can translate it to an algorithm, and we can apply this algorithm to a number of surfaces, a number of lines, and sort of like make this process more automatic or more efficient within the constraints. So now we have a line. I'm actually gonna erase all of this. I'm gonna build it from scratch with you guys. So we all have this line. First thing I need to do is move this line in Y, right? Or copy it in Y. One important thing in Grasshopper is that there's no copy. When we want to copy something, we move it. And you can move it a number of times. So that gives you like a series of copies. So let's move this object. Double click and type move. And this by default moves it 10 units in Z. But I wanna build my truss on the XY plane. Thank you. So I'm gonna give it a Y vector. If you guys double click and type Y, this gives us a unit Y. So a vector that's 0, 1, 0, right? See? 0, 1, 0. And I can change the Y unit by inputting a different value here. So if instead of this one being 1, I want it to be, I don't know, let's say 11.0, I can plug a slider to the input of the Y vector. See? Okay, what's next to create my truss?
You said divide it, no?
Divide the curve into a number of points, right? Is everyone following? Yeah? Okay, cool. So every time I'm kind of like looking for something that does something similar to what I want to achieve, I can just double click and start typing. So double click and type divide. There are a number of options: divide domain, divide curve, divide length. So divide a curve into equal length segments. Divide length, divide a curve into segments with a preset length. Both divide a curve, it's just a matter of the method. Let's say I want to divide the curve by a given length. So this takes an input, curve to divide, and a length of the segments. Let's say I want my segments to be, I don't know, 3.0. These units again are dependent on your model space, whatever Rhino has set to. But wow, this is a lot of points, so I can play with it. Let's say the length of my segments is 10. Okay. What else do I need to do?
No, the cross section, right? You need the points at the bottom.
I need the points at the bottom. So what I can do is just grab this one, copy and paste it. if you guys notice, when I copy and paste a component, it keeps the connections, the previous connections. One thing can be kept constant, or should be kept constant, in this case the length of the segments. But I need to change something, which is the curve that I'm dividing. Instead of dividing this one, I'm going to divide this one. Okay, cool. What's next? Lines among the points. So that's easy.
No, but you need by every other point.
Let's do that one next. Let's start with lines among all the points. So double click and type line. Cool. Now what's next? Diagonals. What do you guys think? What do we need to do to make diagonal lines? We need to skip one point, right? So instead of going from 0 to 0, one thing that we're gonna start talking about is indices. So these points, they are all contained within a list. A list is kind of like a bucket that contains several elements, right? And within the list, in order to access a specific point, we want an index. An index is kind of like the address. So indices in computer science and a subset of computer science, which I guess is visual programming languages, start with 0. So the first point in the list is going to have an index 0. So in this case, we're joining, we're making a line from point 0 to point 0, right? Point 1 to point 1. So what do we have to do if we want to go diagonally? 0 to 1, 1 to 2, 2 to 3. So we need
1 to 3.
Sorry, 2 to 3.
Yeah.
0 to 1, 1 to 2, 2 to 3. Right? So we need to kind of like shift the order of the list. And luckily, there's a component called shift. Double click and type shift. All right. So we can shift the top or the bottom list. It's up to you, but I'm gonna do it with the bottom line. All right. See, this is what I was talking about. All the points. This is a point representation in Grasshopper. Have an index. The index is on the left. It starts at 0, 1, 2, 3, 4. So instead of referencing the whole point coordinates, you just reference the index. What's going to happen to this list once it goes through the shift component? Which one's going to be the first element of the list? This one, right? See? You guys see it?
And who knows what will happen to the first item which is not there?
Does that make sense?
Yeah, can you zoom out so we can see your connection?
Yeah.
Is that good?
Yeah.
So what just happened? This point was shifted to the first element, right? What do you guys think happened to this point? It went to the last position. Yeah. It's just like shifting the order of the points.
So is it the default that it's shift by one? That's why.
Exactly, that's the default. But we can tell it otherwise. So you guys look at this input grab values true. If we don't want that value to go to the end, all we need to do is add a false statement. So double click and type toggle, boolean toggle. This is kind of like the switch, the on and off switch. Okay, so now what I'm gonna do is just make a line between the original points and the shifted points. Make sense? Yeah? Okay. What do you guys think if would happen if I set this to true? If I add the last element of the list at the end? I'm gonna get a very long line, yeah. Good. Now let's make this lines a surface. One quick and dirty way of making surfaces out of lines is creating pipes. So if we double click and type pipe, we can easily make those lines into pipes. A pipe has a curve to follow and a radius. Good? Any questions?
Easy.
So you just made all the lines into pipes.
I transformed the lines into pipes, yes.
Okay. Cool.
All right, 10-minute break.
Take me up here.
Cool. Oh yeah, it's your
No, turn in the recording off.
Oh yeah.